Okay, the note at the top isn't relevant to the rest of the calculations. That's worth taking a quick look at. The expression, if I put a bracket, 0.9, comma, 0.2, semicolon, 0.1, 0.8. This means that there's a row consisting of 0.9, 0.2, and a row consisting of 0.1, 0.8. So that the matrix, when written this way, when you write it by hand and when you actually work with it, should be written like this. A row consisting of 0.9, 0.2, a row consisting of 0.1, 0.8. Now, we proceed to multiplying the matrix. And we had instructions for multiplying a matrix, but we want to make sure that you understand that and you really want to see it. So, I'll note that the first row of the matrix is 0.9, 0.2. And the first column of the second matrix is 0.9, 0.1. So that when I multiply the first row by the first column, I'm multiplying 0.9 by 0.9, as we do here, and 0.2 times 0.1. That is, my row is 0.9, 0.2, my column is 0.9, 0.1, and this row times this column is what you see here. So, we can do these, and I emphasize that you shouldn't be reaching for a calculator to do this. 0.9 times 0.9 is 0.81. 0.2 times 0.1 is 0.02, and you add those and you get 0.83, and you should be able to do that in your head. If you can't, please consider practicing more arithmetic in your head. Okay. Now, from this, we conclude, well, actually, no, we're not there yet. If we complete the rest of the multiplication of this matrix by this matrix, now let me back up. Okay, this is the first row and the first column. Where does this go in the product matrix? Well, this product, 0.83, goes in the first row and first column, since it came from the first row and first column. Okay, we complete the multiplication of this matrix. We multiply the first row by the second column. And when we do that, we have 0.9 times 0.2. What's that? Okay, 0.18. 0.2 times 0.8 is 0.16. 0.18 and 0.16 is 0.34. Then we do the second row times the first column. 0.1 times 0.9 is 0.9, and 0.8 times 0.1 is 0.8. 0.9 and 0.8 add up to 0.17. 0.1 times 0.2 is 0.02. 0.8 times 0.8 is 0.64. The sum is 0.66. That's from the second row and the second column, and it goes in the second row and the second column. Okay, so most people did that correctly on the homework, but we just wanted to make sure we had a good visual picture of it and reinforce that. Okay, so now if the A matrix is 0.9, 0.2, 0.1, 0.8, same matrix we have here, then this tells us that A squared is, well, what's A squared? It's A times A. That's what A squared means. And that gives us 0.83, 0.34, 0.17, 0.66, same as this matrix. Okay. Now, our initial population vector for the original sane and demented problem, we chose 400, 600. So that column vector represents the initial population of sane and the initial population of demented people. If we multiply A by 400, 600, we get 480, 520, as you verified. And I don't think anybody had serious trouble verifying that on yesterday's homework. Okay. And then if I do A times 480, 520, and I haven't done that because, of course, I believe everybody did that for homework, we get 536, 464. Now, what have we done? We've taken the 400, 600 and multiplied it by A. We've taken that result and multiplied it by A. And we've gotten this. And this represents the population after two transitions. After the first transition, we get this. To start, we have this. After one transition, we have this. After two transitions, we have this. Now, if we multiply this matrix by A squared, it ought to, or this column vector by A squared, it ought to come out the same as what we had here. Let's check that out. because A squared is A times A, and what we've done, starting with 400, 600, we've multiplied it by A, then we multiplied by A again. So we've multiplied by A squared. Okay, and now A squared is this, multiplied by 400, 600. 0.83 times 400, another calculation you should easily be able to do in your head. 4 times 8 is 32. So 0.8 times 400 is 320. 0.34 times, I'm sorry, okay, 0.8 times 400 is 320. Or, yeah. And 4 times 3 is 12, meaning that if we multiply 400 by 4 by 83, we would get 32 plus 0.12. You can do it in your head, but that's going to add up to 332. Okay, and then 0.17 times 400, 17 times 4 is 68, and 0.66 times 600. 6 times 6 is 36, and this 6 times 6 is 36. It's going to give you 360 and 36. You'll have to think about where the decimal places go, but the arithmetic of doing these multiplications is simple enough, and you should know your basic calculations well enough, and your multiplication tables and so forth well enough that you can easily do that. And of course, I don't necessarily expect that you can do that right now, but you should do more mental arithmetic so that you can at least get to the level of being able to do these calculations in your head. Much beyond this, it's nice to be able to do it, but at a certain point you will go to calculators and computers and spreadsheets. Okay, so anyhow, if we add up the 332 and the 204 that we get here, and the 68 and the 396 that we get here, we get 536, 464. I didn't go over the multiplication point 34 by 600, but it comes out 204. And that one's really pretty easy. 3 times 6 is 18, so you get 180. 4 times 6 is 24, 180 and 24 is 204. Okay, and these additions are easy. Anyhow, this, matches this, as it had better do, if this is to make sense. Okay, that's your basic idea of multiplying two matrices, and also of using the squared matrix to get a two-year transition matrix.